As I work through the next few practice problems, I want you to pay careful attention not just to the final answers, but the notation that I'm using as I work through this process. You'll be expected to produce answers with proper notation on free response problems, as well as be able to identify correct notation and understand what it means when you're looking at multiple choice problems. So we're going to start with 742. This is talking about an electronic circuit. The design of an electronic circuit calls for a 100 ohm resistor and a 250 ohm resistor connected in a series so that their resistances add. The components used are not perfectly uniform, so the actual resistances vary independently according to normal distributions. The resistance of a 100 ohm resistor has mean 100 ohms and standard deviation of 2.5 ohms. So I'm going to pause right there and jot down a couple things. First of all, we have our first distribution. It tells us it's normal with mean 100 ohms and standard deviation 2.5. And appropriately named, that's the 100 ohm resistor. As I continue to read, then I find that our 250 ohm resistor has a mean of 250 and a standard deviation of 2.8 ohms. The other piece of information that I'm going to write down here is that it says not only are the distributions normal, but they vary independently. That's extremely important. As we combine these two resistors, as we combine their distributions, we need to know that the distributions are, or that the processes are independent of one another in order to combine their variances. We could combine their means regardless, but we can't combine their standard deviations if they're not independent. So if this independence piece were omitted from the problem, we wouldn't be able to do anything with the variance or the standard deviation. All right, moving on. For part A, what is the distribution of the total resistance of the two components in series? So I've got these two variables here. I'm going to call them X and I'm going to call them Y. I'm going to write a new random variable W to be the addition of these two pieces. So if I want to find their distribution, that means I need to find the mean and standard deviation. So the mean of W would be the mean of X plus Y, and as we've talked about in class, we can just add the means directly. So we'll take 100 plus 250, and we get a combined mean of 350. Be careful of your units because we are talking about ohms here, and we want to make sure that we're consistent throughout in talking about our units, especially in problems where the units might change. So if we're talking about millions of dollars and you're given something in thousands of dollars, you'll need to make those units consistent with one another. Here, it's not that big of a deal. So I'm going to move on to my next slide, but I'm not done with problem A, because to find the distribution, to find the distribution, I need to also find the standard deviation. So the standard deviation of W is the standard deviation of X plus Y, which is the sum of their variances, so the squares of the standard deviations, take their sum and then square root it to get it back into a standard deviation. So we have 2.5 squared plus 2.8 squared. Take the square root and you should get approximately 3.7537. There we go. So that means our final distribution will be normal because the combination of two normal random variables also follows a normal distribution. It will be normal with mean 350 and standard deviation 3.7537. And so that is our final answer for part A. Part B for our electronic circuit problem asks us to find the probability that the total resistance lies between 345 and 355 ohms. We're going to show our work here. So we want the probability that the total resistance, which we've named W here, lies between 345 and 355. If you hadn't defined the variable to be W and you wanted to work through the problem just calling it the sum of the two random variables, you could. And similarly, instead of naming them X and Y, you could have done X sub 1 and X sub 2. Doesn't matter. So I'm going to draw a picture, as I do with any probability problem concerning the normal distribution. I have 350 in the middle for my mean. I'm going up to 355, down to 345, and we want the probability between, so I'm going to shade that space. Remember, you always need to include a picture with these calculations on both my exams and the AP exam. What we need to do next is change these probabilities into z-scores. That way we can use table A to find our answers. So I'm going to write this by taking my value of interest, and on the left side it's going to be 345, minus 350, the mean of the resistance, divided by the standard deviation. Now we found the standard deviation to be 3.7537 in the last part of the problem. But what you might see sometimes on the AP test is instead of calculating the standard deviation in and of itself, it might just give the formula for the standard deviation in the denominator. So it might look like this, and I just don't want you to be thrown off by that should you see it. So we're going to do the same thing on the other side. 355 minus 350 all over the square root of the sum of the variances. Running into my picture here. Okay, something I want you to keep in mind is that because 345 and 355 are symmetric about the mean, then their z-scores should be the same as well. Their z-scores are telling us the number of standard deviations away from the mean, and so we should get, well, when I say the same, same but opposite signs, we should get the same values when we do these calculations. So once I plugged this into my calculator, I got z-scores of negative 1.33 and positive 1.33. Another word about the notation that I'm using. We have these P statements ahead of my parentheses because we're talking about the probability of something happening. So it's kind of like function notation, f of x. At this point, once I find z-scores and I use the table in the back of the book in order to find the probabilities associated with these z-scores, then I no longer write the probabilities anymore. So I'm going to go to my picture. I'm using my table as well to look up these values. If I look up the z-score positive 1.33, I get a value of 9082. And remember, that's the area below that piece of the curve. And then if I look up negative 1.33, I will get the complement of what we found for the positive. And then in order to find the area in between them, we're just going to subtract. And you're always going to show on any written problem that you subtract these two values so that the reader knows what you did to come up with your final answer. So this is our probability, about 82%. And then, of course, again, if it were a written problem, you would want to put your final answer in context in a sentence. And so we would say something like, there is about an 82% chance that the total resistance lies between 345 and 355 ohms given these distributions. And that would be it.